Welcome to my 12th tutoring session in A-level chemistry. In this video, I'll talk about isoelectronic series and later discuss some practice questions to gauge your understanding of the concept. What is isoelectronic series? Isoelectronic series refers to a group of atoms or ions that have the same number of electrons but different nuclear charges. Let me explain this concept with the help of an analogy. We have an electrically neutral atom with 4 electrons and 4 protons. We have a cation with 4 electrons and 5 protons. We have an anion with 4 electrons and 2 protons. Now these three, they belong to the isoelectronic series. Why is that? So iso means same. So isoelectronic means these three series of ions, they have the same number of electrons. Now what about protons? They have different number of protons, and let's see how the varying number of protons have effect on its respective sizes. In case of cation, the size of the cation decreases because there is increase in positive charge, and as a result of increase in positive charge, the attraction increases and repulsion decreases. So it is not that there is no repulsion. Repulsion is there, but the magnitude of attraction dominates over the repulsion because the number of positive charges is greater than the number of negatively charged electrons present in the ion. And as a result, the cation shrinks in size due to the increase in the effective nuclear charge. Now, what is effective nuclear charge? It refers to the electrostatic force of attraction between the positively charged protons in the nucleus and the negatively charged electrons. Or you can put it this way: effective nuclear charge is the positive charge or the net positive charge experienced by electron in an atom. Now, I have discussed the topic effective nuclear charge in detail in one of my previous videos, and I have given the link in the description. You can follow that. And what about anion? The size of the anion increases because of the increase in the negative charge. There are 4 electrons as compared to 2 protons. So repulsion increases. So it is not that there is no attraction. Attraction is there, but the magnitude of repulsion dominates over the attraction. And due to the increased repulsion between the electrons, the electron shell or the cloud expands. And this leads to the electrons occupying more space. And as a result, the size of the anion increases. And the effective nuclear charge decreases due to the decreased number of protons in the ion. What about the electrical neutral atom? Now the size of the neutral atom, so there is neither an increase or decrease in the size of the neutral atom. So in case of neutral atom, as we all know, there is an equal number of protons and electrons. The positive and negative charges cancel each other, leaving the atom with no net charge. So how do you order them? According to their sizes, or how do you arrange them in a sequential order? Now the size of the cation is less than the neutral atom, and neutral atom in turn is smaller than the anion. So you should be very careful about using the mathematical sign, that is increasing or decreasing sign. So You're supposed to make use of the appropriate sign that is required, depending on the question that is asked. So the question may be asked with reference to arranging the ions in the decreasing or the increasing order. Now, why elements phosphorus, sulfur, chlorine and argon are not isoelectronic, while phosphide, sulfide, chloride and argon are isoelectronic? Now, the elements in question are phosphorus, sulfur, chlorine and argon. Now, all the four elements, they are not isoelectronic. Why is that? Phosphorus has 15 electrons, sulfur has 16 electrons, chlorine has 17 electrons, while argon has 18 electrons. So you can see that all the four elements have different number of electrons. Therefore, they are not isoelectronic, and therefore they have different electronic configuration. Now, when phosphorus is indulged in a redox reaction, it gains 3 electrons and changes to a phosphide ion with 18 electrons. Sulfur, it gains 2 electrons in a redox reaction and changes to sulfide ion with 18 electrons. Chlorine gains 1 electron indulging in a redox reaction and changes to chloride ion having 18 electrons. And argon, being a noble gas, has the most stable electronic configuration and it is chemically inert and it has 18 electrons. So now you can see that all the four, they have the same number of electrons, that is 18 electrons, and therefore they are now isoelectronic, the same electronic configuration. So phosphorus, sulfur, chlorine and argon, they are not isoelectronic because they have different number of electrons, while phosphide, sulfide, chloride and argon have the same number of electrons and electronic configuration. That is why they are isoelectronic. Now moving on to the next question. Arrange fluoride, phosphide, sulfide and chloride ions in the order of decreasing size. Now, whenever you come across a question where you are asked to arrange the ions in the order of either increasing or decreasing size, you can follow the steps. Like step 1 is to find out whether the given series is isoelectronic or not. So you have to count the number of electrons. Step 2, if it is isoelectronic, the given series, count the number of protons, and on comparing the number of protons, you can have an idea about the size of the ions, saying it is smaller or bigger in size. If the given series of ions, they are not isoelectronic, then you can count the number of shells and identify their position in the periodic table. Now, if you're not comfortable with this 3 steps, you can use this particular scheme. So if the given series of ions, if they are isoelectronic, you can count and compare the number of protons, and the ion or atom with the more number of protons will be smaller. If the given series, they are not isoelectronic, then you have to find the element's position in the periodic table, and after that count the number of shells and compare. So the ion or atom with the more number of shells will be bigger. So my advice to students who are beginners in chemistry will be to memorize the first 20 elements in the periodic table. So memorize their symbol, chemical name and atomic number. Now some universities, they provide you with the periodic table, while some universities, they don't allow the periodic table. So to be on safer side, we can always memorize the first 20 elements of the periodic table with respect to their name, symbol and atomic number. So if the given series is isoelectronic in nature, count and compare the number of protons, and the ion with more number of protons will be smaller. And remember these two formulas. Now the positive charge will be inversely proportional to the size of the ion. That is to say, if the number of positive charges are more, the size of the ion will be smaller. And if the number of positive charges are less, then the size of the ion will be bigger. And more the number of negative charges, larger will be size of the ion. Okay, now let's see whether this particular scheme works or not with the help of an example. The question is, arrange fluoride, phosphide, sulfide and chloride ions in the order of decreasing size. So what will be step 1? As per the scheme, find out whether the given series belong to the, that is whether they are isoelectronic or not. So let's find out whether the given series belong to the isoelectronic series or not. So you got phosphide with 18 electrons, sulfide with 18 electrons, chloride ion with 18 electrons, but fluoride ion with only 10 electrons. Now in this series of 4 ions, only 3 are isoelectronic in nature. Why? Because all these the ions, they have the same number of electrons, that is 18 electrons. So step 2 will be, if the given series or the ions are isoelectronic in nature, you have to count the number of protons. So you have to find the proton, the ion with more number of protons. So here you find that chloride ion is the one with more number of protons, that is 17, as compared to phosphide and sulfide ion. And therefore, it will be the smaller ion. So the ion with more number of protons will be smaller. And therefore, the order will be phosphide greater than sulfide greater than chloride ion. So you have come to this particular conclusion because phosphide, sulfide and chloride ions are isoelectronic with the same number of electrons, and therefore the ions with more number of protons will be smaller because of increase in the effective nuclear charge. Now what about fluoride ion? So it is not isoelectronic in nature with respect to these 3 ions, and therefore move to the next step, that is find the element's position in the periodic table and count the number of shells. So fluorine, if you check the periodic table, is a period 2 element with only 2 shells, as compared to the phosphide, sulfide and chloride ion with 3 shells. So the ion with less number of shells will be smaller. So therefore chloride ion is the smallest among the given ions. And therefore the arrangement of ions in the order of decreasing size will be, phosphide will be the bigger sized ion and fluoride ion will be the smallest among these ions. Now moving on to the next question, arrange nitride, oxide and fluoride ions in the order of decreasing size. Now the ions in question are nitride ion, oxide ion and fluoride ion. Now all 3 ions, they have equal number of electrons, that is they have 10 electrons, and therefore they are isoelectronic. So what will be the next step? So now we know that the given series of ions are isoelectronic in nature. So move on to step 2, that is count the number of protons and compare the number of protons in each ion. So nitride, oxide and fluoride ions have 10 electrons in their shells, but fluoride ion has more number of protons as compared to that of nitride and oxide, and therefore which will be the smaller one. So the smaller one, or the smaller ion will be the one with more number of protons. So here you can find fluoride ion with 9 protons as compared to oxide with 8 protons and nitride with 7 protons. So the order of decreasing size will be nitride will be bigger than oxide, bigger than fluoride ion. And remember this formula, that positive charge is inversely proportional to the size of the ion. So here you can see as the number of charges increases, there is a decrease in size of the ions. Moving on to the next question. Now this is interesting and bit tricky. Arrange iodide, bromide, chloride and fluoride ions in the order of decreasing size. So these 4 ions, they are not isoelectronic in nature. That is to say, they have different number of electrons. So if you follow the scheme that I've just explained, when the given series of ions, when they are not isoelectronic, you have to compare the sizes based on their position in the periodic table and the number of shells they have. So we're not bothered about the answer at this point of time. So let's find out why the ions are arranged in this particular order. Now this is a simplified and condensed version of the periodic table, considering only the important elements required. Now in the periodic table, down the group you can see that elements are organized in rows called periods with reference to number of shells. That is period 1, period 2, 3, 4 and 5. So each period corresponds to a row. And across the period, elements are organized in columns called groups. So this is based on the number of valence electrons. Now we can see that the ions in question, they belong to the group 7. So we find all the elements in question in group 7, and these elements belong to group 7 with 7 valence electrons. So we're not interested in the number of valence electrons. So you are interested in the comparing the size of the ions. So period 1 elements, they have 1 shell. Period 2 elements have 2 shells. Period 3 elements have 3 shells. Period 4 elements have 4 shells. And period 5 elements have 5 shells. Now fluorine is a period 2 element with 2 shells. Chlorine is a period 3 element with 3 shells. Bromine is a period 4 element with 4 shells. And iodine is a period 5 element with 5 shells. Now down the group, as the number of shells increase, there is a corresponding increase in the size of the element or the corresponding ions. And therefore, we can say that iodide ion is bigger in size as compared to bromide, chloride and fluoride ion. So only when the given series of ions in the question when they are isoelectronic, you can count the number of protons. If they are not isoelectronic, then you can find the position of the elements in question in the periodic table and compare them with respect to the number of shells. Yeah. Now time for some practice questions relating to the isoelectronic series. Now, which is bigger in the following pairs? Aluminum ion or magnesium ion? So let us follow the same scheme what I have explained. So in case of aluminum ion, you have to count the number of electrons, it is 10. And in case of magnesium ion, the number of electrons is 10. So they are isoelectronic. So answer is yes, it is isoelectronic. So what will be the next step? So now you know the given pair of ion is isoelectronic. So next step will be you have to count the number of protons. So aluminum ion has 13 protons while magnesium ion has 12 protons. So using the formula, the ion with more number of protons will be smaller because of greater effective nuclear charge as compared to magnesium. And what about the second, question, sodium ion or fluoride ion? So once again, both are isoelectronic in nature with 10 electrons. So sodium ion has 11 protons while fluoride ion has only 9 protons, and therefore the one with the lesser number of protons will be bigger in size. So magnesium ion will be bigger, and the second one, fluoride ion, will be bigger in size as compared to sodium ion. The next question, which is smaller in the following pair, potassium ion or chloride ion? So once again, follow the same scheme. Check whether they are isoelectronic. So both potassium ion as well as chloride ion both have 18 electrons, and therefore they are isoelectronic. Yes, they are isoelectronic. So count the number of protons now. So potassium ion has 19 protons as compared to chloride ion with 17 protons. So here the question is, which is smaller in the given pair? So the smaller will be one with more number of protons. So potassium ion has 19 as compared to chloride ion with 17. So there will be smaller. So third question, identify the isoelectronic species in the given combinations of atoms and ions. So it is not oxygen, it is oxide ion and magnesium ion. Now both oxide ion and magnesium ion both have 10 electrons, and therefore they are isoelectronic. So what about the second one, the second pair? Magnesium ion and sulfide ion. Magnesium ion has 10 electrons while sulfide ion has 18 electrons. So each ion has different number of electrons, and therefore the combination is not isoelectronic. So here are some homework questions relating to the isoelectronic series. Now if you are finding it difficult to answer some of these questions, now feel free to comment me, and I'll be more than happy to guide you solving these questions which are finding it difficult to find the answer. Now don't forget to share, subscribe and like my video. Thank you so much for watching my video. I hope you enjoyed it, and I'll see you in my next interesting tutoring session.